Thank you very much. I'm not sure that we can compete with the rhythm of my previous speaker, but we will try to match that. We have allocated each company from the presenting companies a very short time, so you will be aware of what they are doing, what type of collaboration, idea, and partnerships they're looking for. We will start with the panel is to present very shortly to the audience some of the relevant technologies being developed or under development in Israel. We will start with a consortia of researchers from academy and industry, a short presentation of the TEPS consortia, dealing with energy storage for vehicle, and then we'll continue for short 3-minute speeches of 12 Israeli technological companies. So in order not to take more time, I call Dr. Yigal Klein from TEPS to make his short presentation. Thank you.
When Henry Ford started manufacturing the Model T car, Model T had two versions, electric and gasoline. And after a short time, the electric car was terminated because of poor performance and high cost. Actually, the range was too low. Nowadays, 100 years later, almost everybody is convinced that EV is there should be a transition to EV, and the main obstacle to the proliferation of electric vehicles is the power source. We at the TEPS consortium, who are sponsored by Magnet and by the Alternative Fuels Administration of the PMO, we set very ambitious goals for our consortium in order to make an impact in this field. We believe in innovation. We're not trying to follow anybody else, but to develop our own technologies. And we also strongly believe in international collaboration. We have four clusters. One is the lithium ion, the supercapacitors, fuel cells, and metal air, and overall the integration, as Professor Chan said, the power management system to integrate the system. We rely on the know-how of the industries in Israel, and the 8 professors who are partners in this effort, who are leaders in their field of electrochemistry. And the main theme of our effort is innovation. Our concept is to develop full electric power system for full electric car, and it has 2 modules, energy source module and the power source module. Altogether, it's a hybrid, EV hybrid, but hybrid of electric and electric. They quoted in this conference that the price of gasoline is $3 a gallon if you go to a service station, to a gas station. Actually, a study showed that the real price for society is $10 a gallon, because you have to weigh in the effect of air pollution and the greenhouse effect. So there is a major economic incentive to go into EV on the long run. We have 5 industries which take part in this effort, in this consortium: Elbit, Tadiran, ETV, Celera, and Epsilon. Some are major companies, some are SMEs, some are startup companies, and they work together, they collaborate in the way that Dr. Avi Hasson from the Ministry of Economy described. they partner, they share the know-how, they assist each other in order to develop these demonstrators. Our goal is to develop breakthroughs in technologies. We are interested, there are many international guests here in this conference. We are truly, we believe that international collaboration is a must, and we look forward to share with you our goals and to work together with anybody who's interested. And there are emails here that we have also a website, TEPS.org.il, and we look forward to people who are interested in collaborating with us. Thank you.
Thank you very much, Igal. I would like to call the first technological company Danziger. And then get ready, the next one would be, so Danziger, I don't know if you've heard. The next one would be Elbit.
Good morning.
All of you, you have pointers.
Yeah. Okay. Danziger Dan Seeds, owned by Danziger Farm, is a family-owned company, more than 60 years already, mainly in the floriculture business, but recently started also seed business and started with a castor and some other biofuel crops. We are going to establish, and we are already in a process of negotiating with partners, castor integration, because the castor beans production over the world suffer from some problems, and we believe that there is a high demand for this oil, for the castor oil, mainly for biofuel needs, but not only. But the problem is the agrotechnical in the field is very bad, or is not good enough, and probably won't be able to compete other crops in the field, so probably farmers won't grow castor, it won't pay. So the reason or the object of this integration is to find a way to work together, the breeders and the farmers and the oil producers, in order to find the best way to do it. But the first bottleneck will be in the farm. We believe that the Israeli genetics and breeding capabilities, together with the Israeli farmers, the agrotechnics, can do it probably best in the world, or can lead the world in it. And this integration, if it succeeds within the next few years, probably will be a kind of a platform that will be pilot, which can be copied all over the world to other countries, because Israel, of course, is just a laboratory for this. What we see now for the next 2 or 3 years, our goal is to get the strategic partners, maybe some financial partner, together with governmental funds, and the immediate needs that we see is for the next 3 years is $2.5 million US, and of course we'll have a detailed business plan for potential people who are interested to show. We'll be very happy to invite you to join this venture. Thank you.
Thank you very much, Gabi. Now we've heard a company in the area of biofuels. Now we'll hear a company in the area of electrical storage, Elbit. After Elbit, it's GTLF. I'll see.
Hi everyone, my name is Yuda from Elbit Systems. I'm leading a team that is developing supercapacitors for energy storage application. Our current focus is transportation, automotive start and stop, batteries and supercapacitors hybridization. Currently, we are working on a supercapacitor with an energy density of 5 watt-hour per kilogram. And we are planning to launch 2 new products this year, one for start and stop application and the other for engine start. We believe that the key for electric vehicle, especially in urban transportation, is fast charging, and there is a big competition between batteries and supercapacitors. Most of batteries manufacturers today are working on faster battery charging, and supercapacitors that already have the fast charging capability are working to increase the specific energy. Our next generation that we plan to launch in the near future will have 10 watt-hour per kilogram, but we have much more aggressive plans that by the year 2020 to reach around 100 watt per kilogram. That is very close to what you get from a power lithium-ion battery. And we believe that this will open basically a big range of public transportation EV application using supercapacitors, where the major advantage comparing to batteries will be safety, will be fast charging, and basically also price. What we are seeking to collaborate with automotive manufacturers and lead acid battery manufacturers in joint development, testing, and implementation of our supercapacitors for the current generation. And we are also seeking to collaborate with universities, research institutes, and entrepreneurs on the next generation of supercapacitors. You're more than welcome to approach me and see how can we do things together. Thank you very much.
Thank you very much. GTLF. Next one is Kenaf.
We develop a process to capture CO2 from any combustion source, mainly power plants, combine it with natural gas. We have a reactor which you demonstrated here in Israel in a small scale, and we are working in an environment of gas-to-gas phases. We are going right now to build our commercial unit, which you see a picture on the wall, in United States. And it's going to be implemented in a power plant in Louisiana, a 1,500 megawatt power plant. By the end of 2016, we will be able to produce 30,000 tons of methanol a year, and that's going to be a breakthrough in the, with the arrow. We shall be able, at the range of natural gas, which we have tremendous, United States, Israel, Arab countries all over. So at $4 per million BTU, we shall be able to process a barrel of pure GTL, low sulfur, at less than $60, and methanol at less than 220, where current prices are like 400 and 450. And we are looking for business partners, which are oil and gas wells, flare gas refinery, people who are emitting CO2, producing fertilizers, ethanol plants, and also investor. The key that we have our technology is very small when compared to other technology, so we don't have to invest billions in order to make a production facility, and we can start with as low as like few millions, and by that we can make distribution energy. You don't have to import a vessel of crude from Bahrain to New York, distillate it in New York, and ship the liquid distillate to Chicago. We can take the natural gas from pipeline in Chicago and produce their own fuels for the local demand. Thank you very much.
Thank you very much, Asi. Kenaf. After Kenaf, movie.
Kenaf Green Industries is a small company working with Kenaf for the 15 last years. After we see that in United States, Australia, and even Israel, there was a big success with Kenaf, we decided that this is a challenge, and we can say that after that years, we are ready to begin with the project of Kenaf. Kenaf is a green raw material for many industries. Toyota and Ford already has vehicles that use Kenaf component, and the reason that they are not using more Kenaf is that there is no supply. And this is exactly the answer that we are able to give. We know to grow Kenaf. We grow Kenaf in many countries, in Ethiopia, in Kenya, in South Korea, in Italy, Greece, and the United States, and also in Central America. We have good technology and new varieties and hybrids of Kenaf, and we also developed some industrial line for producing Kenaf non-woven, Kenaf insulation material, and Kenaf is also a good replacement for wood for the paper and corrugated pulp. Thank you.
I think you don't want to finish your. I don't want that for technical reason. So you have another half minute.
The Kenaf plant in this picture is 100 days age. Means it's grow very fast, and we can grow in the tropics 2 cycles a year. In Israel or some other countries like United States, we can grow it only in the summer.
Thank you very much. Movie, and then new CO2 fuels.
Hi. The city as we know today is full of ineffective way of transportation. So we thought thinking about going to the basics. We spoke here about freedom, about moving around the city, on the open air, things we have already forgotten. So we are developing this vehicle that's called Movie. It's portable, as you see. You can carry it with you anywhere you go. You can connect between all the way of transportation, put it in the luggage of the car, go on a train, on the bus. And then, once you want to ride around town, just open it, and in 2 seconds, you have a vehicle that can carry a grown-up person to 30 kilometers. Zero emission, of course, batteries up to 25 kilometers per hour. Very convenient, very safe to ride, very simple to ride. No gizmos, no gyros, nothing, just pure fun, pure electric fun. We are now starting the commercial phase of this product. We are looking to start pilots all over the world with municipals, campuses, big factories that need to cover long distances. Of course, later on, investors, resellers, everything that is needed to go for a worldwide operation. Thank you very much.
Thank you very much. David, new CO2 fuel. And then next one is Finergy.
Good afternoon. My name is David Banit. I'm the CEO of New CO2 Fuels. It has been largely spoken about methanol as transportation fuel in the last day and a half. And we are contributing to this effort on the other side by, how does it work? Here, by producing methanol. The product of NCF is producing methanol from carbon dioxide and water using high temperature heat from renewable sources. So not only that we provide clean methanol, but rather at the same time solving some CO2 emission alleviation. The sources of the renewable heat can be either solar, or it could be other sources such as the steel industry, gasification, glass, ceramics, etc., where they can take these two waste stream of CO2 and heat and get a stream of revenue. A product like that, at the price of methanol of $450 per ton, which is the current price, will enjoy an internal rate of return of more than 25% IRR unleveraged. The product is very flexible and can accommodate the different sizes of heat sources depending on the end customer. And in addition to that, as you may see here, the fuel that we produce is actually syngas. It's a mixture of hydrogen and CO. So primarily, methanol is the best product, but it can be adjusted to produce any other chemical or fuel that the end customer would like to produce. 3.5 years ago, we licensed the technology from the Weizmann Institute of Science. And since then, we have managed to build 2 prototypes utilizing 2 different heat sources. One is the solar and the other one is excess heat. Both outperform the performance that we expected at that level. And right now we are moving forward to the higher or the larger capacity in something like 18 to 20 months. We're going to install a pilot of about 200 tons per year at one of the largest steel manufacturers in Europe. We collaborate with other partners or potential customers in a variety of industries. All these achievements have so far been able to perform by our investors on one side and the governmental support from the Ministry of Energy and Ministry of Economic in Israel, and also from the DOE in the United States. And we are looking for additional partners. We're a small company entering the big boys markets, and strategic partners, whether funding or industrial, will be more than welcome to join us. Thank you very much.
Thank you very much. Finergy. After Finergy, Primos.
Hello, I'm Aviv Tzidon. I'm the co-founder and CEO of Finergy. In Finergy, we're doing metal air using aluminum as a source of energy. And I would like to share with you something about aluminum. Aluminum is 8% of Earth's crust. It's very abundant metal, and it's very rich in energy. And the way we store energy in it is the existing technology of smelters. So charging aluminum is actually done where electricity cannot be sold otherwise, and it's usually cheap. And when it is next to hydro, it is also clean. And imagine to yourself that one can discharge at time, at will, this aluminum to electricity using either electric car or using a generator behind a meter. And the intention when we started this company a few years ago, 6 actually, is to resend aluminum back to aluminum hydroxide to be back to aluminum. And the idea is to use aluminum as a source or a vehicle to bring clean, renewable electricity to where you want to need it. But in the process of development, using the skills of Alcoa that we jointly developed our things, we learned that our aluminum hydroxide, the byproduct of the aluminum while creating energy, is very valuable. And it can serve as chemical grade and actually can shift the value of kilowatt hour to be competitive with gasoline, even changing price of gasoline, and it can be a zero emission well-to-wheel because the credit of not doing aluminum hydroxide derivatives as it is being done today give you a credit for that. So we have an energy which is zero well-to-wheel. And if you take 1 kilogram of aluminum with 1 liter of water and 1 kilogram of air, you create actually 3 kilograms of aluminum hydroxide, and a car can use it for more than 30 kilometers, and this is the formula. And our timeline, with the 40 seconds left, technology that was developed in Bar Ilan for 8 years, we started the company around that. We are doing R&D in a stealth mode for 4 years, and in 2012, we demonstrated a car that you can see outside using 25 kilograms of aluminum to ride 1,000 kilometers. In 2013, we teamed with Alcoa and have Renault as an OEM that we are integrating a serial car with this technology. And since then, we have more OEM. In 2013, Barack Obama visited Israel, and we were selected to show it as an oil choices alternative. 2014, we demonstrated a boat integrated with our aluminum. And in 2015, we are working now on a generator that will either do a peak generation or will be as an emergency generator. Thank you for your time.
Thank you very much, Aviv. Primus. Dr. Samia. And the next one is soft wheel.
Okay. My name is Yom Tov Samia. I'm in this industry for about 9 years. I'm in all renewable, sun and alternative fuels or biofuels. My basic beliefs after 9 years in this industry and from the top of my age are 3 basic assumptions, and with all the respect to the new innovations, once you don't act under those 3, you are in trouble. 1, you cannot change consumer behavior overnight. 2nd, you cannot change state infrastructure overnight. And the 3rd, subsidies are not forever. So due to those 3 assumptions, we are focusing on drop-in fuel, either based on biomass or natural gas in this case. And we presented with one of our subsidiaries called Primus Green Energy in the United States. It's 3 stages. Basically, we are taking natural gas, convert it to syngas, then we scrub it, clean it up, and through our IP, 4 reactors, closed loop. It's not Fischer-Tropsch, it's much simpler than Fischer-Tropsch. That's why we can use also small plants and be economics. At the end of the day, we have 93 octane gasoline or whatever octane you needed. Next year, we're going to have the biodiesel, and the year after, we're going to have a jet fuel. It's all drop-in fuel. You don't need to change any of the infrastructure or your car or the consumer behavior. We can compete with about $60 per comparable to $60 per crude oil barrel cost. This is our plant in Hillsborough, New Jersey. It's not exactly Israeli technology, but it looks like a Babylon tower. We have more than 7 Israelis there, Chinese guys, Indian guys, American guys, Russian guys. So it's the positive way of Babylon Tower, all speaks English and Hebrew. And this plant already makes 6 barrels per day. And I'm happy to announce in these very days that we are approaching our 2 first commercial plants. One in East Europe. I can't say the country yet. It's a public company for 500 barrels per day to give them a solution instead of flaring their natural gas out of their oil field. We convert this natural gas to gasoline. And the second project will be in Houston, United States, with 2,000 barrels per day, and that's all will start in 2015. Thank you very much.
Thank you very much, Yom Tov. Softwheel, and then Tour Engine.
Good afternoon. My name is Amichai, and I'm with the Softwheel. Well, the wheel is one of the most important inventions in the history, especially for transportation. It enables moving things from one place to the other efficiently. With time, technology came up with the suspension ideas to make it safer and more comfortable. Recent rise in focus on personal mobility brings new challenges to suspension and to wheel manufacturing and the designing. And we at the Softwheel believe that this should be looked at in a new way. Technology at the Softwheel actually enables having a suspension that is symmetrical. It's selective. That means it doesn't move on the flat surfaces, and it reduces the unsprung mass, which means that just the rim is unsprung. This is especially important for hub motor purposes, for example, in electric vehicles. We are currently working on wheelchair solutions, which is a very problematic market that has no real solution for suspension, and urban bicycles, especially e-bikes, which have the problem of suspending the torque and suspending the hub motor. The future, as we see it, is in everything that has a wheel. And we believe that at some point, suspension will have to be effective and comfortable at the same time. Thank you very much.
Amichai, we have 30 seconds more. If you can say what type of partnerships or you might be looking for.
Well, currently we are looking mainly for strategic partnerships, both in manufacturing and in marketing.
Thank you very much. Tour Engine. We have 3 more to go. Tour Engine, Transbiodiesel, and Univerve.
Hello. First, I want to thank the organizers for inviting me to introduce Tour Engine, and the Ministry of Energy for supporting our initiative. My name is Ehud Sivan, Dr. Ehud Sivan, and I am the COO of Tour Engine Israel. Tour Engine is developing a revolutionary and out-of-the-box internal combustion engine, and revolutionary in the fact that simulation predict that it would be more efficient by far than regular combustion engines, 20 to 50% more, and consequently it would be would have less emissions proportional to that efficiency increase. But more important, or at least as important, is the fact, that it is based on simple components, standard components, and as such, it would be very easy to adopt by the industry. So what have we achieved so far? We have 3 operational prototypes demonstrating the mechanical feasibility of our design. We have 7 issued patents worldwide, and we have more pending. And lately, thanks to major technical breakthrough, we are engaged now in intensive discussions with leading OEMs, and we have a new investor, Dr. Erwin Jacobs, from one of the co-founders of Qualcomm. What are we looking for? As expected, we're looking for money raise. What the goal is to actually build the first state-of-the-art engine that is based on our design that would fully demonstrate the potential of our design. And what we think is that both investors and OEMs have the opportunity going with us. Investors can lead the next round. Whoosh, I'm losing my voice, I'm sorry. Investors have the opportunity to lead the next round, invest in a unique platform, and enter a large market with several multiple verticals, and also connect with other OEMs. And OEMs have the opportunity to have a joint development with us, and or equity investment, and or exclusive licensing opportunities. So I only had 2 slides, not 100 and not even 80. So I'll be available offline to discuss it more. Thank you very much.
Thank you very much. Biodiesel.
Good afternoon. The company was established in 2007 as a technology incubator company. From the very beginning of the first one before. Yeah. From the very beginning of the company, we have focused on developing a new type of biocatalysts for the production of biodiesel, which are capable to convert any type of oil feedstock to biodiesel. The main feature of the biocatalyst or the enzyme should be, first of all, should be cost effective, competing economically with the conventional catalysts which are available in the biodiesel industry to produce biodiesel, especially from high quality feedstocks. And the second feature of the enzyme should be environmentally benign, not polluting the environment, in the contrary to the chemical processes which are very much polluting the environment. So what we have developed during the last 5 years, a biocatalyst which is capable, first of all, to convert the first generation feedstocks. I mean here the high quality feedstocks like soybean oil, sunflower oil, palm oil, similarly to the conventional chemical catalysts, to biodiesel and glycerol, and also at the same time to convert low quality feedstocks to biodiesel. Low quality feedstocks are distinguished with their low price cost, such as waste cooking oil or used cooking oil, and even the lowest quality feedstocks such as brown grease, which is collected from wastewater treatment plants, to produce biodiesel complying with the international spec. So actually the technology enables the move from first generation feedstocks, first generation biodiesel, to second generation feedstocks and second generation biodiesel. So during the last 3 years, we have actually in 2011, we started to claim that we have the product in hand, and we started to commercialize it worldwide. Nowadays, we have pilot plants and also industrial scale plants worldwide, starting we have in Japan, we have in Korea, which is the biggest one. It is our flagship plant in Seoul, which is producing 30,000 or 32,000 tons per year. We have in Indonesia, which is a very important source of oil in the world. We have 2 small clients in Israel, We have also in England, in the US, two plants. One of them is very big plant, and a very small plant in Brazil. So nowadays we offer our immobilized enzyme to the international market to biodiesel producer to exchange or to replace conventional catalysts. Recently,
so one last sentence.
Yeah, recently we started to partnership with clients worldwide to create a JVs because we know that as the technology works, we partnership with industry or with partners who have approach to feedstocks and produce together biodiesel to the international market. Thank you very much.
Thank you very much, Subhi. Ranan, Univerve, please.
Hello, my name is Ranan. I'm a partner and a co-founder of Univerve. Univerve is a company that developed a technology for economic cultivation of microalgae. At the beginning, we established the technology towards production of biofuel. And since then, several conclusions came into mind. In order to make biofuel from microalgae, you need to have three elements combined all together. One is a fairly unique and very economic technology, which we invested about 4 years of R&D in that technology, which you can see here. Second thing, if we're talking microalgae, microalgae has several components in it, and oil, which is the component that goes into biofuel, is just a part of it. The main advantage is that the rest, or the other components that you can take out of the microalgae, has much higher value. And it allows us actually to produce oil in very, very, very cheap prices. And the third element, and probably the most challenging one, is the upscaling. Upscaling is a very, very big problem. And here in Israel, unfortunately, we cannot produce enough biofuel. Let's say we don't have enough land, enough water, and enough resources to produce biofuel. So we're looking for partners around the world that will be able to produce such large technologies. Here you can see a photo of, let's say, a few days ago, of our first farm here in Israel. This farm is actually aiming to produce biomass for food supplements and let's say, other high-value products. But it can show and prove our potential for scalability. What we actually do, we build something which is called BioUnit, based on the unique patented ponds that you see in front of you, which are V-shaped. This BioUnit can be doubled several times. Then we create like a macro unit, and this macro unit is being doubled and tripled, and that's how we scale it up. Second, what's here?
One last sentence, please. What are you looking for? What are you interested in?
We're looking for today, in terms of biofuel, for partners to be able to establish large-scale farms. We're talking about 5,000 to 5,500 hectares to 1,000 hectares. China, Brazil, US, we are in discussions, or advanced discussions, with such collaborators and potential investors. Thank you very much.
Thank you very much, Ranan. I want to wrap up this session saying, like, from the government side, we do not pick winners. We try to let good technologies flourish, and then the market decide what the market wants to get in. You've had interesting testimonial for that. You've seen various approaches, various technologies from totally different approaches. Again, for whomever of you who is interested to continue a dialogue, this was only, of course, a teaser, if you haven't noted. So you can continue with with the companies of interest to further at lunchtime and later on. Thank you very much.